warp, not from any physical obstacle, but from the immense gravitational footprint of a nearby monster. This is the domain of WASP-178, a star of colossal proportions and terrifying energy. It is an A-type star, a cosmic furnace of the high-mass sequence, burning with a brilliant, blue-white light that is more than double the size of our Sun and radiates at temperatures exceeding 9,000 Kelvin. The light it casts into the void is not the gentle, life-giving gold of our local star, but a harsh, ionizing flood of ultraviolet radiation that sterilizes everything in its path. As the camera draws closer, a dark silhouette begins to take shape against the blinding white disk of the stellar giant. It is a world of impossible dimensions, a planet that should not exist according to the older, gentler theories of planetary formation. This is WASP-178b. It is a gas giant of the most extreme classification, an ultra-hot Jupiter. At first glance, it appears as a massive, dark sphere, but as the camera approaches the boundary where the star's light grazes the planet's edge, we see that this world is not solid. It is a bloated, turbulent ball of gas, puffed up by the unimaginable heat of its host star to nearly twice the physical radius of Jupiter, yet possessing only 1.5 times its mass. This extreme inflation gives the planet a bizarrely low density, a structure so loose and expanded that if one could find a bath large enough to hold it, the entire world would float like a cork upon the water. The planet orbits its star at a distance so close it defies imagination, just over 8 million kilometers from the stellar surface. This is a mere fraction of the distance between Mercury and our Sun, meaning a year on this world. The time it takes to complete a full orbit lasts less than 2 Earth days. The camera plunges downward, diving headfirst into the outer layers of the planet's dayside atmosphere, where the true violence of this environment begins to manifest. As we cross the threshold into the exosphere, the silence of space is replaced by a low, rushing roar that exists only as a conceptual vibration of atoms hitting the camera's hypothetical sensor. The heat here is not a passive warmth, it is an active, destructive force. On the dayside hemisphere, which is permanently locked toward the star by the tidal forces of gravity, the temperature has climbed to a staggering 2,400 Kelvin. At this temperature, the chemistry of the universe is rewritten. The molecules that we associate with gas giant atmospheres, methane, water vapor, and ammonia, cannot exist. They are torn apart, their chemical bonds shattered by the relentless bombardment of ultraviolet photons. Instead, the atmosphere is a glowing, incandescent soup of ionized atoms and vaporized metals. The visual landscape within the upper atmosphere is a swirling, violent haze of deep violets, electric blues, and brilliant whites. There are no clouds of ice or water here. Instead, the clouds are made of vaporized rock and titanium. The camera moves through a massive, ascending column of gas that is being heated from below, rising like a thermal elevator into the upper reaches of the sky. Here, the spectroscopic signatures of the atmosphere reveal a composition that sounds more like the inventory of a geology lab than a weather report. The space telescopes of humanity peer through the light years to dissect this light, detecting the presence of vaporized iron, magnesium, silicon, and aluminum. The very elements that form the rocky crust of the Earth, the mountains, the valleys, and the stones beneath our feet, are suspended here as a glowing, transparent gas, drifting through the stratosphere like steam rising from a hot cup of tea. As the camera descends deeper into the intermediate layers of the dayside atmosphere, the pressure begins to build, and the light becomes increasingly diffused. The blinding white glare of WASP-178 is scattered by the metallic haze, creating a sky that glows with a heavy, brassy light, a continuous, featureless vault of white-hot heat. The camera tracks a vast wave of silicon monoxide gas, a compound that has been detected in abundance in the atmosphere of WASP-178b. This compound acts as a gaseous precursor to silicate rocks, meaning that the sky itself is filled with the raw ingredients of stone, waiting for the temperature to drop just enough for them to condense into solid rain. But on the day side, that drop never comes. The heat is constant, relentless, and absolute, baking the planet's face in an eternal noon that has lasted for billions of years and will last until the star itself runs out of fuel. The camera rises once more, escaping the heavy, metallic smog of the lower dayside to look at the planet from a global perspective. From this vantage point, we can see the incredible scale of the atmospheric escape that is occurring every second of every day. The intense energy from the host star is heating the upper atmosphere to such an extent that the planet's gravity can no longer hold on to its outermost layers. A massive, glowing tail of hydrogen, helium, and vaporized metal is seen streaming away from the planet, pushed back by the powerful stellar wind of the A-type star. WASP-178b is literally evaporating, bleeding its mass into the vacuum of space, leaving a long, ghostly trail of ions in its wake as it races along its orbital path. It is a world in a constant state of self-destruction, slowly but surely being consumed by the very star that gives it its terrifying beauty. The camera now begins a long, sweeping transit toward the terminator line, the razor-thin boundary that separates the day side of eternal fire from the night side of perpetual shadow. As we approach this threshold, the visual atmosphere begins to shift. The brassy, white-hot glow of the sky starts to deepen into a bruised purple, then a dark, metallic blue. The temperature differential between the two hemispheres is the driving engine of the planet's meteorology. On the day side, the temperature is hot enough to melt titanium, while on the night side, shielded from the direct glare of the star, the temperature drops by nearly 1,000 degrees. This immense difference in thermal energy creates a pressure gradient of unimaginable proportions. The air does not merely flow from the hot side to the cold side, it screams across the terminator in a supersonic jet stream that circles the entire planet. The camera is caught in this jet stream, swept along by winds that travel at speeds exceeding 3,200 km per hour. To put this in perspective, these winds are several times faster than the speed of sound on Earth, capable of tearing apart any structure or vessel designed by human hands. The visual representation of this wind is a chaotic, streaking blur of metallic vapors, whipping around the curvature of the planet like a global hurricane. As we cross the terminator, the star WASP-178 begins to sink below the horizon, its brilliant white light stretching out into long, distorted fingers of violet and crimson as it passes through the thick, metal-laden air. The transition is not gradual, it is a sudden plunge into a deep, impenetrable darkness, a shadow so thick and heavy that the camera's perspective must rely on the faint, internal thermal glow of the planet itself to resolve the landscape. We are now on the night side of WASP-178b, a place where the sun never rises and the sky is a ceiling of black iron. But this shadow does not bring peace. The temperature here, though lower than the day side, is still a scorching 1,400 Kelvin, hot enough to melt gold, copper, and iron. As the supersonic winds carry the vaporized metals from the day side into this cooler hemisphere, the sudden drop in temperature triggers a planetary scale phase change. The vaporized silicon, iron, and aluminum begin to condense out of the gas, forming clouds of liquid rock and molten metal. The camera descends into this dark, turbulent cloud deck, where we are surrounded by a storm of liquid iron rain. The droplets of molten metal catch the faint, deep red thermal glow of the planet's interior, falling through the sky like a shower of burning sparks, a heavy, metallic deluge that coats the lower atmospheric layers in a fluid, shifting ocean of iron and silicate slag. The camera drifts through this metallic downpour, capturing the sheer alienness of the weather. There is no soil for this rain to hit, no solid ground to collect the liquid metal. Instead, as the iron rain falls deeper into the high-pressure zones of the planet's interior, the increasing heat vaporizes it once again, sending the metallic steam back up into the atmospheric currents to repeat the cycle. It is a closed, self-sustaining loop of metallic weather, a hydrological cycle where water is replaced by iron, and clouds are made of stone. The camera moves through a massive, swirling vortex of liquid enstatite and quartz, a gemstone cloud that refracts the faint, scattered light of the night side into brief, ghostly flashes of green and blue, before being swallowed once more by the dark, heavy clouds of iron. The perspective shifts once again, pulling back from the turbulent depths of the nightside atmosphere to rise above the cloud deck. From here, looking back toward the Terminator, we can see the sheer violence of the atmospheric circulation. The supersonic winds do not just flow in a simple path, they twist and turn in complex, planetary-scale waves, creating massive, swirling eddies of hot and cold gas that battle for dominance along the boundary of light and dark. The dayside hemisphere appears as a glowing, white-hot dome of energy, while the nightside is a dark, churning abyss of metallic storms, separated by a boundary of constant, supersonic chaos. The scale of this planetary engine is a humbling reminder of the sheer variety of worlds that exist beyond our small, quiet corner of the universe. The camera continues its upward journey, moving higher and higher until the entire planet is once again visible against the blackness of the void. From this distance, WASP-178b looks peaceful, a silent, bloated giant drifting in its eternal dance around its brilliant, white-hot companion. The violent winds, the liquid iron rain, and the vaporized stone are all hidden beneath the smooth, spherical silhouette of the gas giant, visible only as subtle variations in the light that passes through its outer atmosphere. The narrator's voice, which has guided us through this journey with a quiet, measured intensity, reflects on the significance of this extreme world. WASP-178b is not just a curiosity, a cosmic oddity to be catalogued and forgotten. It is a critical laboratory for the study of planetary physics, a place where the laws of nature are pushed to their absolute limits, allowing scientists to test their models of atmosphere, gravity, and chemistry under conditions that could never be replicated on Earth. As the camera begins its final, slow backward glide, withdrawing from the WASP-178 system, the planet and its star begin to shrink in the frame. The blinding white light of the A-type star, which has dominated our view, gradually softens as the distance grows, returning to a single, brilliant pinpoint of light among the millions of others in the constellation Lupus. The heavy, resonant vibration that has accompanied our journey begins to fade, replaced once again by the profound, clean silence of the interstellar vacuum. The screen slowly darkens, the stars fading one by one into the velvet blackness, leaving only the memory of a world of fire and iron, a place where the sky rains metal and the rocks are made of gas, suspended in the quiet, infinite dark of the cosmos.